of images for square corner reflector. Square corner reflector antenna. Okay. So square corner reflector antenna means, so what is the value of n? N is equal to 2. How many images will be there? 2n images, that is 4 elements will be there. Okay. So first, this is my original feed element. Okay. So opposite polarity. Okay. Same. This is opposite polarity. So what is this total angle? The total angle here it is. The angle is 90 degrees. Okay. So the angle is 90 degrees. Alpha is equal to 90 degrees. So this is the main beam. This is the main beam. Okay, so let us consider point P. What is the total electrical field? Let us calculate it. So what is the P? Here, total number of elements are 4 elements are there. Okay, so this is 1, 2, 3, 4. These 3 are images. All are separated by a distance. Yes. All are separated by a distance. Yes. Okay. So consider a square corner reflector with alpha is equal to 90 degrees. So the reflector consists of one driven element. So this is our driven element located at a position 1. Let us consider this is position 1. Okay. So 3, 2, 4. Why I have given the numbers like this? Because 3 and 4 are same type. 1 and 2 are the same type. Okay, so totally one driven element and 3 images will be there. One driven element. This is one driven element. And 3 images will be there. So the driven element along all the 3 images carry current of same magnitude. But current in driven elements and its images are in phase, while the current in image elements 3 and 4 are out of phase by 180 degrees. The current present in the driven element 1 and 2 are in same phase. But whereas in 3 and 4, the current is 180 degrees out of phase. Okay. So out of phase. Okay. Next. the electric field in a horizontal, plane at a distance r. So this is the r, some point. Let us consider this point P at a distance r of an antenna is given by, so E phi of theta is equal to, this is the expression K dash into I1 into cos alpha s cos theta minus cos alpha s sin theta. So where I1 is the current in each element. I1 is current in each element and K dash is constant incorporating distance r. Okay. So S is distance between the feed element and vertex. S is the distance between feed element and vertex. Okay. S is the distance between feed element and vertex. Okay. Next. The terminal voltage. Of driven element. Is given as, so V1 is equal to I1 Z11 plus I1 Z12 minus I1 Z13 minus I1 Z14. So why I have taken here minuses for third element and fourth element? Because they are 180 degrees out of phase. But first element and second element are in same phase, where Z11 is, what is this Z11? Self-impedance, okay, of driven element. Okay, self-impedance of driven element. Self-impedance of driven element. That is approximately for lambda by 2 type of. Okay, 73 ohms. Z12 is mutual impedance between 1 and 2. Z13 is Z13 is equal to Z14, that is mutual impedance between 1 and 3 and 1 and 4. So therefore, V1 is equal to Z11 plus Z12 minus 2Z14, 2Z14 into I1. Okay, 2Z14 into I1. So for example, if power P is supplied to the driven element, to the driven element, the power output in each image, in each image also same, remains same, that is P. Therefore, now the power can be expressed in terms of I1 as P is equal to I1 square into R. So this from this I1 is equal to root of P by R. So therefore, so here if you observe here, the if V1 by I1, it is nothing but Z11. Okay, so it is that is equal to I1 by V1, that is the resistance, that is the combination of Z11, Z12 minus 2 or 2Z14. Okay, so this can be written as I1 is equal to root of P by, here what is the resistances? You can call it as, if we convert into resistances, R11 plus R12 minus 2R. So it is R11 plus R12 minus 2R12. Okay. So if we consider the resistive parts of all impedances, putting the expression in the above this expression in the I can substitute in this expression the value of I. Okay, so substituting, let us consider this as equation A. Okay, so let us consider this as equation A. So now I am substituting the value of I1 here. Okay, this equation. Now let us substitute this equation I1 in A. Okay, so now my expression E phi of theta is equal to A dash into root of P by R11 plus R12 minus 2R14 into cos of alpha S cos theta minus cos of alpha S sin theta. Okay, so this is, let us consider. If the reflector is removed, for example, if the reflector is removed, if reflector is removed, if reflector is removed, okay, so no image element can present. So that is R12 is equal to R14 is equal to 0. Then only half wave dipole as the driven element remains. Okay, so the electrical field associated with the electrical field, the electric field associated due to lambda by 2 dipole antenna, lambda by 2 dipole antenna is given by E phi of theta of lambda by 2 equal to k dash, since there will be no images. Okay, so it is k by p. Okay, so let us consider this in the expression p. Okay, so now the gain in theta direction, the gain in theta direction is multiplying the above equation A by B, multiplying the above equation A by, sorry, now multiplying, so the above equation B, let us consider this is C, B by C, dividing by B by C. So the d of the theta is equal to E phi of theta by E phi of theta of lambda by 2. So this is E phi of theta and this is E phi of theta lambda by 2. So if you substitute, we will get R11 by R11 plus R12 minus 2R14 into cos of alpha s cos theta minus cos of alpha s sin theta. Okay, where root of R11 by R11 plus R12 minus 2R14 is called coupling factor. Is called coupling factor. And the term cos of alpha s cos theta minus cos of alpha s sin theta is called pattern factor. Is called pattern factor. So this value is called this value this value is called coupling factor, and this value is called pattern factor. So this value is called pattern factor. Okay. So the radiation pattern will be like this. So this is due to 1, this is due to image 2, this is due to image 3, this is due to image 4. Okay. So the same thing we can generate for uh, 45 degrees, 90 degrees. Okay, so for 45 degrees, total how many images will be there? 7 images and one real thing. For 60 degrees, there will be 6 total elements are 6. That 5 images for. Okay. So for getting maximum radiation, simply put theta is equal to 0 here. Then we'll get the same expression in forms into the cos of beta s minus 1 into this term, because this is for final. When theta is equal to 0, the same expression will get cos of beta s minus 1. Okay. So this is regarding method of